Okay, so today we're going to move on to chapter 7. So I'm going to go ahead and have this closed, of course. That's how the world works. Schedule where we're at, where we're headed, how we're going to get there.
You got another exam.
That's what we're talking about. It's today. I did give a pop midterm once. I gave a pop midterm once. It was cool. It was a class that didn't have any exams and all this work. So I was just curious how they were doing. So I thought, I'm going to give a pop midterm. It didn't count, but still, there were several students that were like, not. I had to revise them after. I just like the idea that I'm giving a pop midterm. That just makes me feel very, very good about myself. It didn't count. It's okay.
It doesn't count.
So there was only like 10 seconds. They didn't know it didn't count. They were in panic mode. See, I like to go for the obscure records. I once fouled out of a basketball game in 3 minutes and 20 seconds.
That's awesome.
I once missed 23 free throws in one game.
Wow.
And I wasn't a bad shot, but I was a 7th grader playing an 8th grade team, and they had like multiple centers just beat the crap out of me, basically. I was so shell-shocked. And I scored 13 points before 3-point play, so I must have made at least one of my free throws. So I was 1 out of 24, I believe.
That's better than what Shaq did. They went pros.
Yeah. Yeah, he shot okay, but not that good. But it's cool. I mean, it's a record. I'm proud of it. And fouling out in under 4 minutes. That's
impressive.
That's team effort. I had to have a coach that was dumb enough to leave me in the whole time. And I had to have bad referees. Okay, why can I not get sunscreen?
You say your internet wasn't working?
It wasn't. It seems to be okay now. That gonna work? Okay. So here's where we are now. So we're going to cover 7.1 through 7.4 today on this. 7.5 through 7.7 on Wednesday. Lab tomorrow, of course. No class Thursday or Friday, so no class in here on Friday. When we come back from fall break, Monday, we're going to finish up chapter 7, 7.8 through 7.10. In the rest of next week, on Wednesday and Friday, we'll start covering chapter 8 on strings. We'll finish up strings on that next Monday. Okay, that's the 18th. Okay. Then the 20th will be a review, and the 22nd will be the exam. Okay. So that's where we're headed.
How many exams did you Yeah, you saw that final.
Yep, that's it. That's all we got.
Does the final exam counts different?
The final, yes and no. It's supposed to be 20% for the first 2 exams, but a lot of people do crappy on the first one, so you can kind of drop one. And the final itself is what, 20%. So it's pretty much the second exam or the combination of 2 that helps you, or that's worth 20%. The final's worth 20%. I went ahead and calculated midterm today, more or less. I got to find a way to get it to you in some reasonable fashion. Homework is killing some of you. Not necessarily in this class, but in general. It's half your grade. So,
Oh, like great.
yeah, because we're about midterm. Next week's midterm. And the first exam will not kill you long term. Kill some of you short term. It may kill you over the midterm break, but it won't kill you long term as long as you do well in the last 2 exams.
Okay. So if you do like really well the first 2 exams,
yep,
and you did bad on the final,
yep.
Bad then?
Yeah, the final's final. Final, I can cut you some slack on the first exam,
But final.
I can't cut you slack on the final. I mean, it's all, I have a responsibility when you leave here for your next class for C++, that you have a certain level of competency. If you don't have it early on, that's okay for exam 1. But if you don't have it at the end, then yeah, your grades need to reflect that. Okay. So I've graded the homework that was due Friday. And then I'll grade the homework that was due today soon. Okay. So if there are questions on that, the homework that was due Friday, I'd already done both of those, one on a video, one in class, the 3 and the 4. So the others I didn't, but we'll do an example of those. I'll probably do the example 9. I'll probably do a video in 9. Some people have said they like to watch the videos. So if I don't do that tomorrow, somebody remind me.
On 10, like how you did how many these files,
Yep.
how would we have done the trial set files? Both of them?
Yes. Yeah, it's a separate, when you're looking, and we'll see this again today, I'm gonna do one of the homework examples today. You look at where an exception could occur, whatever the program is, and you have to capture whatever exception that could cause. Okay, so you're looking for division by 0, you're looking for anytime you do a float or an int, any of those functions could do a value error. Anytime you have a file, the file may not be there, or may be damaged, or various things like that.
What's it?
What's that? That means that the file, the IO's input output system, it looks up something with the file wasn't happening. File name or directory or something, most likely.
So those errors, like the file error and the value error, are those already on the keyword error? Okay.
Yeah, and we'll talk about today in the example. If you don't remember, like on the exam, what kind of an error message you get, just force it. You can force it in your code or force it in the interactive shell, and that will tell you what kind of error it is. Okay, so today we're talking about chapter 7, which is on lists and tuples or tuples. I'll say both. I'll say both every time. I'll say tuples or tuples, and I don't know what the real word is. So this is our first data structure we talked about. Okay, so a data structure, it's important, so much so that the 3rd class you take in computer science is data structures. Okay, you take this course, take C++ programming, you take data structures. Okay. So data structures refer to ways that we can store information in a running program, okay, that make it easier to process. Right now, we just have to store everything in a variable. That's not the best way to do things. Okay? And this is important because we're getting now to have almost all the tools we need. Okay, we started off with the sequential, the selective execution, the repetition. Those are kind of the basics. We, of course, have variables. We have functions. And now we're getting data structures. We have files, exceptions, data structures. It's the next big thing. Okay. So data structures are sometimes in some languages, especially Java, called containers because they contain data. Okay. Those are synonymous terms if you're familiar with that. Okay. So the first kind of thing we're going to talk about today is a sequence. So a sequence is just going to be a series of data elements. Okay. Other languages like C++ and Java implement this via arrays. You may have heard of arrays before, mathematical arrays, all that stuff. Python doesn't do arrays. Python does lists and tuples. Okay, lists are a lot more flexible, a lot more powerful than arrays, and I believe is the reason that Python continues to be a top 3 language in demand. Okay, they're so powerful. When you get to C++, you will be longing to go back and do a list again. Okay, tuples too. Okay. So let's talk about how this works. Do a lot of this in the shell today. Okay. So to create a list, it's real simple. Let's give it a name. Doing a list of even numbers equals. We use the assignment. We use a square bracket. Okay. Python data structures are differentiated by their punctuation. If you put a comma there, you don't have a list anymore. You have a tuple. If you put a curly bracket there, you don't have either of those. You have a dictionary. Okay. So remember, when we're talking about a list, you have square brackets all the time. Okay. What's in it? Or whatever you want. We do that. We now have a list of 2, 4, 6, and 8. Okay. You can also do lists with strings. Okay, many as you want. Okay. And again, in the shell, you can just give the name correctly, though. In code, you would have to print that to get the same thing. Okay, so we're not dealing with them, we're just getting that structure. Okay. Again, one of the advantages to Python, since it's a loosely typed language, we don't have to have only one type of data. An array in any other language has to be all ints or all floats or all strings or all something. In Python, it can be whatever you want. Okay, so I can have something like this. Alicia, 27, 1550.87, whatever that means. Okay, so this record contains a string, an int, and a float. All that is okay. Okay. We can also create quick and dirty list through the list function. So the list function takes what the book calls, what Python calls an iterative or an iterator, an iterative structure. The one we've used is range. Range spits out a range of numbers. Okay. So I can say something like this. I can say numbers is equal to list. I can put range in here. I can put whatever I want. So I can start at 1, go to 100 by 101. And I can put that third thing if I want to skip it. Okay. And now numbers has all that. Okay. So you can quickly and easily create ranges if you have numeric data for your lists. Okay. We can also use the repetition operator, which is the multiplication symbol or the asterisk. So I can say something like list 1 is equal to 0 times 5. Okay. List 1 then has that. Okay. In fact, that's how we typically are going to, the end of today, we're going to get a little bit into section 7.5, talk about a int. But the problem is, until then, if you know you're going to have to input 5 values, you start by making a list with 5 things in it. Okay, so you put 5 zeros in there. Again, that's a list, so this is repeating it 5 times. And that works with anything. So I could say list 1 is equal to 1, 2, 3 times 10. And you create all that stuff. Yep. You can create stuff really quickly. Okay.
Which is available online, especially with the exam.
Yep, it's true. Okay. So when we're dealing with numbers like that. Okay. Looks like numbers a little smaller. Numbers equal to this. 1 to 16, let's say. Okay, let's say I want to iterate through and deal with each one of those items in the list. Okay, I can do that with the for n structure. So I can say for n numbers. Okay, that's going to go through. N is going to take the first number first and the second, all the way until it's done. And I can just print out n. There you go. There's my 15 numbers from 1 to 15. Okay. So note that I can't make any changes to it in this way because I'm returning things from it. Okay. So we're going to get the next thing. If we do a while loop, we can deal with the indices and make actual changes. Okay. So another function we need is the len function. The len function just returns how many elements are in the list.
How did you get
I did a print in and then nothing in between, so it should just give a new line character every time. Okay. So for a while list, I've got more pieces to it. I have to do an index, or we just do I equals 0 to my index, the first number. Okay. And I can say while index is less than the length of numbers. Okay, and in this case, it's 15, and I can't be 15. So valid values are going to go, I didn't do that. Let me stop and do that. Let's talk about the valid values since I'm now dealing with them. Okay, so in this case, we have 1, no. One more. Okay. So the indices for this. In computer science, we start counting at 0. We'll learn more why that happens in C++ class, and it's about memory and offsets, but for now, just assume that's what's going to happen. So the first element have an index of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. So that's why that while loop works. It has to go up to, but not including the length, because that's too far. Okay. One of the other cool things about Python is that it allows you to go backwards pretty easily. Why I hit the red and my whole screen died. And now Excel blew up. All from hitting that one button. I don't know what's happened. It does. This is just Excel. I didn't even do this. Well, while we're waiting on it to come back, the way the negative indices work is that the last element, no matter what element it is, has an index of -1. Okay. The next to last element is -2, -3, all the way up to the negative of the length. Okay. So in this case, -15 would be the highest element. Okay. So this is -1. Okay, that's going to be okay, all the way over. And those are equivalent. They mean the same. Okay. So for example, if we look at the index of 6 and -9, they should be the same number. They should both be 7. Okay. So if I say numbers 6, that's a 7. If I say numbers -9, that's also a 7. Okay. And always numbers -1 is the last element in the array. Okay. So once we have that, we can now go through and do a loop. Okay, we'll do it. Our numbers again, numbers equal to list range 1, 16. Okay. My I for index equal to 0, so I'm going to start. Okay. And then I'm going to continue on while I is less than the length of numbers. Okay, so it's going to start at 0 and go up to 14 because it stops at 15. Okay. So once I'm here, I can just print out numbers sub I if I want. That works. We'll start there. But then I have to set I plus equal 1 or I equal I plus 1. So this should go through and do that.
What is the
Length. How many elements are there? Okay. So this would be equivalent. Again, you'll get the same thing. You print. Show separation here. U for n in numbers. Print in. So if that's all you're doing, the for loop's quicker and shorter and all that. Okay, and both of them do exactly the same thing. The difference is with the while loop, I have the index. So I can do something like double all my numbers. So instead of printing, I can say number sub I is equal to numbers sub I times 2. Okay. I couldn't do that with a 4. So I can print out now the before. And I can print out the after. Okay, so before we're going 1 to 15, after we're going 2 to 30. Okay. Ready, notice. Those. You're slipping. I don't want to squirt it or paintball it. Pepper spray, maybe, something.
That'd be efficient.
It would. You wouldn't do it again. Be my guess. Okay, questions on this?
So why did you have to print the numbers in the bottom part?
I did here.
No, I mean like when you took it from the wild.
Here?
Yeah.
Oh, I didn't need to.
Okay.
I could have. Okay. So something else here. I kill that yet. When you run a program, you kill what's there. List. So we said before we mentioned it, but we didn't talk about it. The idea of mutability. Maybe we can do it here. Lists and tuples. The only difference is lists are mutable, tuples are immutable. Anybody know what mutable means?
Sounds.
What's that?
Sounds.
Nope, not different kind of mute. Mutable means you can change it. Immutable means you can't change it. So in terms of list, and this, a list means you can change the data in the list while the program's executing. You can give it one value and change it. Tuples, you can't do that. Okay. So it means if I want to get to the third element of my list, okay, is a 3, because it's always 0. Okay. If I want to change that to something else, I can say numbers sub 3 is equal to 99. Okay. And now you see numbers has changed. Okay. The 99 is not it. If it wasn't mutable, you wouldn't be able to do that. Okay. Questions so far? Let's take a quick look at problem 7.1 in the book. With this one, we're going to be doing some sales data. So we're going to use a number of days global constant equal to 5. Then in our code, we're going to set up sales. Its initial value is going to be equal to the list containing 0 repeated num days times. Okay. So it's going to give us a list with 5 elements, all of them 0. Okay. Now we're going to set our index to be equal to 0 to start us off. We're going to go through a while loop, and we're going to ask the user to enter sales data for the day. Okay. So we're going to have our while index is less than. We have 2 options here. We could say the less than length of sales, but that's equivalent to num days. You can say num days there if you want. Either one works. Okay. And because our index starts at 0, we want to say day 1, not day 0. We want to do this index plus 1 in our print or in our input. You can't do that in input, it blows up. Okay, so we have to do a little tricky thing here. So I'm going to say day number. Then I want to put the index plus 1. Okay, then I'm going to put a colon, a space. And then to make all this work out, I'm going to let my separator be equal to 2 empty spaces or 2 quote marks, and also my end equal to 2 quote marks. Okay. And the end thing in particular is going to mean when this line prints out, when I go to input, the cursor is still going to be right there. It's not going to, and you'll see why I'm doing this. Okay. So now I can let sales sub index, so starting with 0, going up to 4 in this case, it's going to be equal to just float and then an input. Okay. So again, I'm not putting a prompt in here because it would give an error when I tried to do that. So I'm printing this out. It's going to stay sitting there till we get to here. Okay. And then of course we have to set our index plus 1. Okay, run this so far. Get day 1. Okay, that seems to be working. Okay. And then all we do from there, we just want to print out the values. So to print out, I don't have to worry about the indexes, so I can just do for values in sales. Print. So format the tab first. Tab. Format. Values. That's what we're calling as we go through. Comma point to F. Was. Okay. And that should go through and print everything out. Okay, so I enter 3 and 6.5, 5.4, and 8.2, and 9.9. And that's what it prints out. Okay. So to me, lists feel a little bit like sequentially reading a file. And then we're kind of moving through the file with the for loop. Works in a very similar way.
I like read one.
Yep, very similar. Okay. We can create lists via concatenation, which means if you have a list, 1 is equal to 1, 2, 3, and list 2 is equal to 4, 5, 6. They're both lists. I can say list 3 is equal to list 1 concatenated with list 2. So list 3 is now both of those together. Okay, do this really well. Okay. I can even say list, since it's mutable, list 3 is equal to list 3 plus 7, 8, 9, 10. That's cool. Now list 3. Spell it or type it correctly. Has that as well. Okay. You can concatenate things however you want. And life is good. Okay. Questions so far? Okay, so let's talk about list slices. A list slice is a portion of a list, a sublist. Okay, it's going to be sequential in itself. And we do a slice with the bracket, but instead of a single value, we're going to put in a colon to give a range of values. So, and like the range, it's going to start with the first value, but end before it gets to the second value. Okay? So if we know that list 3, the third position, let's say, is a 4, okay? And I want to go up through the 6, okay? So we're at 0, 1, 2, 3, 4, 5. So I'm going to have to go up to 6 to get the 6 in there, okay? So if I say list, go away, 3, I want to start with 3. I want to go up to 6, but not including 6. Okay, that's going to give me the 4, 5, 6. Okay. So again, that's going to give me starting with 3, 4, 5, but not 6. Okay, so 0, 1, 2, 3, 4, 5, 4, 5, 6. Okay. If you omit the first value, so if I say list 3, nothing, colon 6, it defaults to 0. It starts at the first element and goes up to, but not including the 6th element. Okay. If you delete the second one and say like 3 colon, it starts with that third element and goes to the end. Okay. 3 is actually the fourth element. The the three elements of 0, 1, 2, 3 and goes to the end. Okay. If you don't put anything, this turns out to be handier than you would imagine. We talk about it on Wednesday. A list with just a colon assumes the start to be the start and the end to be the end. Okay. So that's how slices work. Okay. Questions on slices?
So it's like a list of it.
It's like a sublist. But always sequentially. You can't randomly pick stuff with that nomenclature. It's a start and an end. Okay. And you always have to go one more than you think. Because it's like range. Yeah. The only thing that doesn't do that is the rand end. Range does what rand end does. Rand end is the only thing that includes the end. Okay. We can also do the in operator to determine whether something's in our list or not. Okay. So I can say something like 6 in list 3, and we'll say that it's true because 6 is there. If I say 66 in list 3, it's going to return a false because it's not there. Okay. Note that that is not crazy useful in that it doesn't tell us where it's at or if it's repeated times. There are other functions for that, but this is a real basic. You need to know, is it there, is it not there? Okay. So another program we can do, this is on 354, program 7.2. This we're going to use this in. And again, do your comments. I don't, you should. So we're going to have this product number list. The product num is going to be equal to always a square bracket. We've got a V475. We've got an F987. We have got a Q143. We've got an R688. So all we want to do is figure out, we want to allow the user to enter a search term. So search is going to be equal to this input, no product number. Right? When they do that, we're going to check to see. So we're going to say if that search is in our prod num. Okay. If it is, we're going to print found. You can be fancier, but found will get the job done for now. Else, print not found. Okay. So again, lists have built-in search functionality. You have to roll your own on that. So let's go to here. In our product number, if we enter X999, not found. If we enter an R688, it is found. Okay, that is case sensitive unless you do something to convert it. Okay. So that's the in item, which is good. Okay.
For that, like to make it not case sensitive, we just have to do like to where it be equal to the uppercase as well as the lowercase.
Next chapter, we're going to get a function that converts it all to upper or lower, and that is really what you want to do. Okay. So one quick thing that I'm going to work at the homework problem. It's we're going to pull one method out of chapter 7.5, which we're going to cover fully on Wednesday, and that's the append method. Okay. So if I've got a list, if I want to create a blank list, it's just 2 brackets. Okay. So now the type of X is a list. Okay, it's empty, but it's a list. You can do anything with it. You can say for I and X, print I, and it doesn't give you an error. This doesn't do anything because it's empty. Okay. So now I can append data to that. I can say X, append whatever I want. I want to append a 5. Okay. X now has a 5. Say X append a 15. X now is a 15. Add whatever you want. Okay. So when you're going through the homework problems, if you don't want to create zeros and fill it out that way, you can also do the append. Either way. Okay. We'll talk about more of that section when we get. for Wednesday. Okay. I do want to do homework problem 1, which is similar in some ways to the ones that I assigned. I'll let you know how this would work out. Okay. So this is a total sales program. And all I ask us to do is to ask the user to enter a store's sales for each day of the week, and then it's going to use a loop to calculate the total sales and display the result. Okay.
What number did you say for?
Number 1
On 7?
on 402. Yeah. Step 7. Okay. So we can, if we want, take a clue from the book and get the number of days. Let's say we're going to do 5 days. Okay. So if we're going to create our list this way, I can say sales is equal to the list containing 0 num days times. Okay, so that's going to give us that position for day 1 through day 5. Okay. So once I have that, I can go through and ask them the data. Such that my index equal to 0. I can say while index is less than num days or 5, either one, but num days is more generic. We change that. Okay. And again, for the same reason, since I want to ask them for day 1, I'm going to print first. So I'm going to print here sales for day index plus 1. Colon space, my set equal to nothing, and my end equal to nothing. Here. I'm going to print that out, and then I'm going to say S. I'm not good right. To say sales dot index. So the index position, so the 0s and the 1 all the way up to the 4, is going to be equal to a float input. I'm not going to do a prompt because I'm using the print for a prompt. Okay, I'll do that each time through and do an index plus equals 1 or an index equals index plus 1. That's going to get me through there. Okay, let's see if this is working. Okay, I need a space after day. Besides that, we're good. Okay, so now we're going to, again, you should put in comments, going to calculate total. You could do the total as you're doing the rest of it, but it says to do it separately. So I'm going to say for index, for let's say N in sales, total equal to 0. Each time I go through, I'm going to say total plus equals N, add N to it every time through. And I'm going to print total is format total, format it for comma, point to F. Check things out, do $10 every day. So the math's easy. $50 for Yep, I got more changes to do. So which lines do I have to worry about exceptions? What lines could throw an exception? The input sure could. It's not the input itself, but it's the float code. Okay. And float, what kind of error does float give you? A value. Okay. So I need to take all of this. All of this. Tab it over. And this is what I tend to do. I tend to write the program, then I tend to go back and answer. Okay. We need an except here for a value error. Now I'm going to just make it easy for now. You should do a real error. This is going to print whatever the default value is. Okay. What other kinds of error can we have? We haven't really talked about it. I'll skip over this. Okay. So what do we have here? Let's say num is equal to list. Okay. 1 So if I say num 0, we're good. Okay. If I say num 10, we're not good. We get an index error. Okay. So whenever we have a list, we have to make sure we're dealing with the index error. Even though the way we've written this, there's not really a way for this to cause trouble because we're using the length and all that stuff. But just to be extra careful, and assuming that somebody else may be running this program besides us, okay, then we're going to print that error. And you should do better error messages. These are just default ones. So that's kind of the minimum you need on this program as far as protection goes. You can't really test that index error unless, oh, you can do this. If I do that, that will force an error, right? Okay, so that gave us, that's the error from here, this index error, so we know. Take that out of there, and we can run it again and test it. Note, since it's looking for a float, and it's not going to cause us any trouble, but letters would. Okay, and again, that is the value error.
Where do you move like the ERR? Like, how do you
Down here, the message,
Yeah.
It's default. There's a default, Python has a default error message for every error. You don't want to use that though, because it doesn't give a lot of detail. You'd want to do your own custom one, but since we're running out of time, that's what I do. Okay. Question about any of this stuff? So every program that we do now, you want to look for lines that could throw an error. We're looking for division by 0. We're looking for a file not being found, or the file system having some kind of problem. The file could be corrupted. I was grading the homework. I was using the same names.txt. Somehow I got wiped out. There was no values on it. I'm like, 2 people in a row. I marked them off because their program didn't print anything. I'm like, that's weird. The 2 people would have the same issue, and it was my file. It got messed up. Okay. So you want to check for those things. So division by 0, files. Anytime that there's lists, we now have to worry about the index error. Anytime you use an int or a float or any of those things, you have to have the value error.
Do we need anything after except like else?
In this case, you don't. Sometimes you do. It depends. For this to be a better program, this it doesn't matter. Well, yeah, it kind of does. When we're asking for values, we're still not. This is not an A-level program, and that it's not keeping you in a loop until you have something correct. Okay. It should do that, which you need the else for that. But this is just avoiding being an awful program. Okay. So yeah, you do want to make sure if they enter something, if they enter a string, you want to keep them in that. We did that the other day for a while. Okay, so let's go over quickly. We've got 2 minutes left. The homework for Wednesday then is number 2, lottery number generator. Design a program that generates a 7-digit lottery number. Should do randomly between the range of 0 through 9, and then put it into a list. Okay, by another loop to display the contents of the list. Okay, make that look nice. And then in 4, there's a number analysis program. The user is going to be asked to enter a series of 20 numbers. Program should store the numbers in a list and then display which one is the lowest, the highest, the total, and the average. Okay. For the lowest and the highest, I use what's called a king of the hill algorithm. You start by assuming that the first element is both the biggest and the smallest. You then look at the second element. Is it bigger than the first one? If so, now it's the biggest. Is it smaller than the first one? Now it's the smallest. And you go through all of your elements, and at the end, whoever's on top is whoever's on top. That's how we do that. Okay, any other questions? Okay, that's all I got there.